Morning, Pawan. Morning. Akshi Chaudhary, good morning. Pawan, good morning. Prakshi
Good
Chaudhary.
morning, sir.
Am I audible?
Yes, sir, you are audible.
Yeah, those problems are there, no? There. Previous year questions.
Yes, sir.
That questions you do, and we will explain all the problems, okay? So,
Okay, sir.
questions, you take the questions and do, please. First question, second question, second question. All the questions. I'm requesting all the students, please do these problems. Yeah. Who are there? Wasim Akram, good morning. Prakshi Chaudhary, Pawan, Nidhi Chaudhary,
Good morning, sir.
only Meghana, Charmi. Only why very few students were attended. Okay, no problem. Who will attend? For them only will teach, no problem. See here. Have you done this? The first question. During mean life of radioactive element, during mean life of radioactive element, the transaction that disintegrates is fraction that disintegrates, that is the transaction actually, that too you have to find out. So means disintegration fraction.
Sir, option C,
Yeah,
E minus 1 upon E.
yeah, that is correct. How you did?
Sir, by using formula n is equals to n naught
Yeah.
E raised to power minus lambda by T
Yeah.
into T.
So you take that n is equal to n naught into n naught into e power minus lambda t. Is it correct?
Yes, sir.
Lambda t. But what is t? T is disintegration constant, lambda.
Yes, sir.
So n by n naught you can take. N divided by n naught. Final by initial. That is equal to e to the power of minus lambda into 1 by lambda. Cancel these two. 1 by e. So n divided by n naught, that is equal to 1 by e. But what is change in disintegration? That is they are asking. So disintegration fraction means change by original. Change divided by original means 1 minus n by n naught, that is equal to 1 minus 1 by e. So n naught minus n by n naught, that is equal to e minus 1 by e. What is this one? That is delta n divided by n naught, that is equal to e minus 1 divided by e. This is the answer. That is the answer. So they are asking you delta n divided by n naught. Okay.
Yes, sir.
Next, do the second one. What is the second one? What is second one? See. What is the second question? See the second question. This is the second question. Mn is the mass of the neutron and Mp is the mass of the, this is the mass of the neutron, it is the mass of the proton. If an element having atomic mass M has TeV neutron and Z proton, then the correct relation will be, that they are asking. Correct relation. What is the correct relation? What is the correct relation? The effective mass is less than the sum of the individual masses of mass of proton and the mass of
Neutron.
neutron and mass of
Neutron.
yeah. So you know, see, all these are the nucleons. All these are the nucleons. For example, some protons are there, some neutrons are there. Protons are there, neutrons are there. All these are collided together. All these are collided together to form a big drop, like a water drop concept. It is water drop concept. Water drop concept. Collide to form a big drop, they release some energy. That energy is equal to mc square. This m is nothing but delta m. Means some mass should be converted into energy. So the effective mass, capital M, the effective mass is less than the sum of the A minus Z into mass of neutron plus Z into mass of proton. A minus Z into mass of neutron plus Z into, what is A minus Z? That is nothing but number of neutrons. So number of neutrons into mass of the neutron plus atomic number Z into mass of proton. This value is less than the effect. So M is less than this effective value. So mass defect, how you find the mass defect? So mass defect delta M, how you write that mass defect? Delta M is equal to this portion, that is number of neutrons into mass of the neutron plus number of protons into mass of the proton minus M, means that effective mass will give you the mass defect. That you can convert it into energy. So energy is equal to delta M into C square, and this delta M you can calculate in terms of AMU, atomic mass unit. AMU in atomic mass unit. We calculate that one in atomic mass unit. What is the atomic mass unit? What is the atomic mass unit? It is the 1/12 of the mass of the
mass of the carbon atom.
yeah. So 1/12 of the mass of the carbon atom. Right. That is 1 AMU. So equivalent energy 931.5. I think you will get this equivalent energy for 1 AMU is 931.5 million electrovolts. Okay, option 1 is correct. Right. Do the second problem. Third problem, please. Do the third one. This is important problem. This is the previous year problem. This is, if the energy released in the fission of one nucleus is 200 million electrovolts, 200, then the number of nuclei required per second, see, number of nuclei required per second in a power plant of 16 kilowatts is 16 kilowatts. Simple, that is, power is equal to energy by time. Energy by time with the number of enough. So they are asking you this N by T, number of nuclei required per second. So therefore N divided by T, that is equal to P by E. P by E. You do it, please. What is P? That is 16 kilowatts, means 16 into 10 power 3 divided by, what is energy? 200 million. 200 million electrovolts means 200 into million means 10 power 6 into electrovolt means 1.6.
1.6 into 10 raised to power minus 19.
Do it, please. How much you got? How much you got? Do it, please. X of n comma alpha of 3, the lithium 7, n
Then sir,
comma alpha, lithium 3 7. The term X will be shall I do? Pawan,
sir,
shall I do?
wait, sir.
Lithium, lithium 3 7. That they have given. Lithium they have given. Lithium 3 7. So what it this lithium can disintegrate? So it converted into some X. That X you have to find out. X Z, that is the atomic number that you have to find out. And this is A, that is the mass number that also you have to find out. And one neutron. One neutron. Nuclear reaction means it produces the neutrons. So this you have to find out. So how to find this one means how many lithium particles, how many lithium are there? That is 3. 3 are there, na? So 3 are there.
Yes, sir.
So this we can write like this. So this also you can write 3 lithium 7 plus alpha particle 2 4. 2 4. So compare this 3. What is Z value? Z plus 0. Z plus 0 is equal to 3 plus 2. Is it correct? 3 lithium. 3. So
Yes,
3,
sir, correct.
3 plus 2, that is 5. So Z is equal to 5. And A, 7 plus 4 is equal to A plus 1. So A plus 1 is equal to 7 plus 4. A is equal to 11 minus 1, that is 10. So what is X value? That X you can write, that X is what is this one? 5. 5 and it is 10. So 510. 510. So which one is correct? That is 510. What is this X value? What is this chemical symbol for atomic number 5 and mass number 10? Atomic number 5. Yes.
B.
What is B?
Sir, boron.
Huh?
Sir, boron.
Yeah, boron. So for boron, that is 510. That is the correct answer. Please take boron 5. Boron 510. That is the answer. That option is correct. Okay.
Yes, sir. Done, sir.
Right. Next question. Nucleon of deuterium and helium atom is 1.1 million electrovolt. 1 point for deuterium 1.1 million electrovolt and for helium 7 million electron. If two deuterium nuclei fuse to form helium atom, the energy released is. That is the given question. Please do it.
Sir, 23.6 milli-electron volt.
Yeah,
Option D.
correct, Tony. Correct. Right. Have you done that? Please tell me. First you write deuterium, no? Two deuteriums are there. That is H12. So H12, okay, H12 plus two deuteriums are combined together, form the helium. Is it correct? Helium 2, 4. Helium 2, 4. Plus energy Q it produced. First of all, you write binding energy of one deuterium. What is the binding energy of one deuterium? Binding energy of one deuterium. What is the binding energy? Please tell me. One deuterium. What is the binding energy? Binding energy of one deuterium. That is 2 into 1.1. Is it correct?
Yes, sir, 2 into 1.1.
2.2. 2.2 million electrovolts. 2.2 for two deuteriums binding energy. So binding energy.
Sir, 4 into sir,
Yeah.
4 into 7.
Yeah. Binding energy for two deuteriums. That is equal to 4.4 of 4.4 million electron.
Yes, sir.
4.4 million. Now binding energy of helium. Binding energy of helium. Helium 2,4. Four into 7.
7, yes, sir.
That is equal to 28 million electron.
28, yes, sir.
28 million. How you got this 7? How you got this 7?
So number of nucleons is equals to number of protons plus neutron. So,
Number of?
so nucleons is equals to number of protons plus number of neutrons.
Number of protons plus number of neutrons. How many protons are there? How many neutrons are there?
Sir, 4 is protons and 2 is neutrons.
Yes. 4 is the total mass number, that is. Mass number means total number of protons and total number of neutrons. Total number of protons are 2. So therefore total number of neutrons are 2. But how you got 7? That's what I'm asking. This 7. Pawan? How you got that 7? Pawan?
Yes, sir.
Why you got that 7?
So I think it's 2.
Huh?
4 plus 2.
What is the 4 plus 2? How you get that mass energy for helium? How you get that mass defect? How you get the mass defect? That you tell me for helium. Shall I write? For helium, mass defect. For helium, T, for helium, mass defect you can find. How to find the mass defect? Helium 2, 4 means that atomic number is equal to 2 and a number of neutrons is equal to A minus Z, that is equal to 4 minus 2, that is equal to 2.
2, yes, sir.
So this is A and it is Z. Now, how to find that mass defect? So that is
Sir, Z and mass of into mass of proton plus A minus Z into mass of neutron minus M.
Z into mass of proton plus A minus Z into mass of. What is the effective mass of the helium? Effective mass of the helium. What is effective mass? You don't know. Effective mass of the helium.
What, sir?
What is effective mass of the helium? Helium mass.
Sir, 4.
Why it is 4?
Sir, you say effective mass.
Ah, yeah, helium mass. This is. This mass you have to find out, no? How to find that mass? Pawan? How to find that mass? How to find that mass of the helium? Effective mass of the helium. Effective mass of the helium, Pawan? You don't know how to find. How to find the effective mass of the helium? See, effective mass of the helium is 4.00150 AMU. 4.00150 AMU. Atomic mass unit. And proton. Proton is 1.00728 AMU. For proton. Very simple. 1. What is that value? 1.000078 AMU. And what is the effective mass of neutron?
Sir,
Ah,
can you please repeat your question? Due to network issue, I
yeah.
can't hear you.
0.0867 AM. 867 AM. So if you substitute all this, you will get if you substitute all this and this delta m, you will get 0.0304 AM. So that mass defect you will get 0.0304 AMU. This is delta M, mass defect. That is equal to 0.0304 into 931.5 million electrovolt. If you do this you will get 28.3 million electrovolt.
Sir,
Yes.
we can't do like this, kya? To
How?
here first we return helium equation, then here number of nucleon is equals to number of proton plus number of neutrons.
Yes.
From in the question they give bending energy per nucleon of 2h 1h2 and 2h e4 are 1.1 milli electron volt and 7.0 milli electron volt. From that we can find mass of helium that is equals to 4 into 7 and mass of hydrogen that is equals to 2 into 1.1.
Yeah, that also you can. No problem.
Then we find energy released is equals to 4 into 7 minus 2 into 1.1. That is equals to 23.6 milli electron volt.
Yeah, like that also can do, no problem. So this is 28.3 million electrovolt, 28.3. So now energy released Q. That is 4.4. Which is 28 minus 4.4. What is that value? 23.6.
Yes, sir.
23.6 million electrovolt. Where is that value?
So option B.
Option B is correct. Trace. So next to do this one. Which of the following are suitable for a fusion process? Which of the following is suitable for? Which of the following is suitable for the fusion process? Fusion process. So for nuclear fusion process, nuclear with low mass, where it is with low mass is suitable. See. Which of the following is suitable for the fusion process? For fusion process, yeah. So fusion process, that is,
Sir, option B, sir, option B, light nuclei. Option B.
yeah, answer is option B is there, no? What is the option B?
Light nuclei.
Next question. So what is the next question? This one. See, nuclear reaction given by, this is the reaction they have given. See, nuclear reaction given by this one. Z X A Z A, here Y Z plus 1 A minus an electron, and here some has given. What is this one? That fusion, fission, or beta decay. That you have to find out. What it represents. What this reaction represents. That's the what this reaction represents. What that reaction represents. Anybody? I think slowly is coming. Meghna coming. Maya Kumari. Maya Kumari.
Yes, sir.
See what it indicates. What about this? What this indicates? This is symbol E minus 1 0. That is nothing but electron. Electron is nothing but beta particle. Is it correct or not? So that is beta decay. That reaction shows the beta decay. Any doubt?
No, sir.
Now, I think this eighth question also you have to do. Eighth question, see. A deuteron strikes the oxygen. A deuteron strikes the oxygen nucleus with the subsequent emission of an alpha particle. Subsequent emission of identify the nucleus so produced. Means this oxygen gives the alpha particle plus which element it produces. That's the he's asking. Do it, please. It bombarded with the deuteron. Bombarded with the deuteron, this oxygen. O816 plus it bombarded with the deuteron, no? Deuteron. It bombarded with the deuteron. This implies this X you have to find out. Za plus helium. Helium 2, 4. Now you can find out. So Z plus 2 is equal to 8 plus 1. So Z is equal to 7. Is it correct? Z is equal to 7. And here A plus 4 is equal to 18. A is equal to 14. So which component have atomic number 7? Atomic number 7 and mass number
Sir,
14.
nitrogen.
Nitrogen.
Nitrogen. Right. Where it is, this is the answer. Nitrogen.
Option D.
Yes. So next question. Go for next question. This one. Solar energy is mainly caused due to solar energy. Solar energy. Is it fusion or fission? What they have given? Here, you read the
Sir,
fusion of protons during synthesis of heavier element. Is it correct?
Yes, sir.
So fusion of protons during the synthesis of heavier element means that is like a helium. Helium. Next question. 11th question. You see. If M proton respectively, then you write the equation. What is that? Which option is correct? Mass of the nucleus is M. Which is correct? Effective mass is always less than. Is it correct?
Sir, option A.
Yeah.
Option A.
Yeah. Effective mass is less than the mass of neutrons, number of neutrons, and mass of neutrons. Right. Next one. 12th question. See. Uranium 92-238 undergoes successively 8 alpha decays and 6 beta decays. Then resulting nucleus is, if uranium 92-238 undergoes 8 alpha and 6 beta, 8 alpha decays and 6 beta decays, 8 alpha decays and 6 beta decays, then the remaining nucleus is, the resulting nucleus is, that they are asking. Shall I write? Uranium 92-238 disintegrates from X, ZA In the radioactive element, no, directly it can disintegrate. So XZA plus 8 alpha decays, 8 helium 2 4 plus 6 electron -1 0. Now do it please. What is this Z value and what is this A value? That you have to find. Do it. So 92 is equal to Z plus 16 plus a minus 6. How many are there here? Minus 6. Huh? So that is minus 6. Minus 6. I'll write here. Z plus 16 minus 6 is equal to 92. And for this A is equal to 4 plus 0. A plus 4 is equal to, or A plus 4 plus 0 is equal to 238. I can find A. And what is that one? We find it. What is Z value?
Sir, 102.
Z value. Z is 82. Is it correct? See, 16 minus 6, 10. We take that one. Z is equal to 82.
So yes, sir, 82.
82. What is A value?
Sir, 206.
2,
206.
206.
Yes, sir.
Yeah, 206 is correct. So 206. Where I have written that is here, na? So A plus helium atoms. How many are there helium? Helium atoms have the mass number, no? 8 are there. So you take that one. A is equal to how much you got? 206. So which one is correct here to see?
Sir, A option.
Yeah, uranium 82 206 is correct. Uranium 82 206 is correct. A sample of radioactive element has a mass of 10 grams at an instant t is equal to 0. The approximate mass of this element in the sample after 2 mean life years. After 2 mean life years. 13th question maybe. After 2 mean lives.
Sir, you are not audible.
Pawan, is it audible?
Yes, sir.
now you are
Yes, sir.
audible.
Yes, sir. Now you are audible.
Yeah. See, this is a two mean half slice, no? 2 into 1 by lambda. Now substitute there. Here you can substitute. That is n is equal to n naught to t to the power of minus lambda into t means you write 2 into 1 by lambda. Answer these two. Those two can cancel and you write that n naught they have given. I think what's the n naught they have given? 10. That is therefore n is equal to 10 into e to the power of minus 2. That is n is equal to 10 into 1 by e square. What is e square? 1 by e? What is the value of 1 by e? What is e value?
Sir, 1.6 into 10 raised to a minus 9.
What is e value? What is e value? 0.3 e value. 1 by e value is 0.3 or something. And you multiply that 10 into that point, you will get 1.35 grams. Answer is 1.35 grams. 10 into 1 by e square. That is all. Okay.
कमल तूने ये देखी
Okay, na?
Yes, sir. Done, sir.
Next one.
ये
Next question. The mass number of nucleus is.
बीच पे गए थे ना घूमने गोवा पे वहीं फोटो
Somebody is making noise here. Maya Kumari, mute your phone. Maya Kumari.
पीछे वो क्या वो वाला ने नहीं बनाया वो वाला मैंने नहीं बनाया अभी बना दूंगा
Maya Kumari.
मामू को दिखा ये वाला मामू को दिखा
Maya Kumari.
माया कुमारी बोल कुछ माया कुमारी तेरा नाम ले दे
Maya Kumari, please stop your mic.
नितिन ने बोल यस सर
Please mute your phone. Okay. Now, this is the mass number of nucleus is. What is the mass number? What is the mass number of nucleus is? That is sometimes more than and sometimes equal to its atomic number, mass number.
Yes, sir.
So which option is correct for that? Hydrogen atomic mass number is equal. So the mass number is sometimes more than and sometimes equal to its atomic number. That is the option. Next, 15th question you see. What is the 15th question? The masses of neutron. See, the masses of neutron and proton are, they have given this one and this one respectively. If the neutrons and protons combine to form a helium nucleus and mass of this one, the binding energy of the helium will be, binding energy they are asking. Just now we completed now. What is the answer? Binding energy for nucleus, for helium, binding energy for helium. Just now we did it now. What is the answer? Just now we completed that binding energy of helium. What is the binding energy of helium? Rubina? Just now we have completed here, that is binding energy of helium. Binding energy of helium just now we have completed. Why you are not concentrating at that, I don't know. Where we did that binding energy of here, you see this one. Binding energy of helium we can find, that is. What is the value? This is 28.4 or something million electrovolt. Here I can find it, that value, no? Binding energy of helium. See. So binding energy of helium, that is 28.3 or 28.4. So now which option is correct? See. So this is the question. So which option is correct? That is 28 point. This is 28.4 million electrovolt. Option 1 is correct. So this actually you have to remember, no problem, for helium. For helium, 28.3 million electrovolts, that is, or 28.4 million electrovolts. Okay, right. Next question. Next question. In following reaction, the value of X is the reaction. Do it, please. What is this X? What is X? You can find Z and A. This is Z. What is Z and what is A? Do it. Nitrogen and helium, they bombarded together and they produce one proton. What is Z and what is A? Z is 9 minus 1.
17. Sir, A is 17.
Yeah. So what is Z? 9 minus 1, that is 8. What is A?
A is 17.
18 minus 1, that is 17. So oxygen, that is 817. That is the answer. Good. Next question.
Sir, option B, na?
Why? Option B.
It's oxygen, na, sir.
That is the oxygen 870, na? Yeah, oxygen, not nitrogen, no? Oxygen 817 is there, no?
Yes.
Right.
Sir.
Yeah, oxygen only. 870.
Yes, sir.
Yes, that is correct. Oxygen 870. Correct. Next, 17th question. Do the 17th question. A radioactive material has an initial amount of 16 grams. After 120 days, it reduces to 1 gram. then the half-life of radioactive material is important question. This is, do it please. A radioactive material has initial amount of 16 grams. After 120 days, it reduces to 1 gram. It reduces to 1 gram. So how to do this? N by N naught is equal to 1 by 2 whole power n.
And yes, sir.
Yeah, 1 by 16 is equal to 1 by 2 whole power n. 1 by 2 whole power 4. 4 only na? 1 by 2, 2s are 4. Yes, 2 into 2 into 2 into 2, 4, 8, 16. That is equal to 1 by 2 whole power n. Therefore, n is equal to 4. N is equal to 4. So, total time, n into t half, that is equal to total time. Total time they have given 120 days something. So, t half you have to find. So, this is 120 divided by 4. What is the value?
30.
Yes, 30 days. 30 days is correct. 30 days. N into half-life is equal to total time.
Then, sir.
And what about this? You see, a nucleus represented by the symbol Za has, Z is the protons, number of protons, and A minus Z is the number of neutrons. Which option is correct? Option. Yeah, Z is the protons and A minus Z is the number of neutrons. Next, M denotes the mass of a proton and Mn denotes that mass of neutron. A given nucleus of binding energy B contains Z protons, then the mass M they have. Already we did all these things. What is that? What is the answer? You see. So, mass of effective mass you have to find out. What is the effective mass? This is the binding energy. This is the binding energy. So, effective mass is equal to N into number of neutrons into mass of neutron plus mass of proton, number of protons into mass of proton minus the binding energy. So, which option is correct? Option C is correct. Option C is correct. Next. The nuclei of which of the following pairs of either question first, nuclei are isotones. Isotones. What is isotone weight? I will ask one of you. So not for all. I'll ask to whom? Wasim Akram. Wasim Akram. Wasim Akram. Wasim Akram or Kaushi Chauhan. Kaushi Chauhan. Isotones. 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 What are isotones?
Sir, can I?
Same number of.
No, not Pawan. No, I am asking Kaushi Chauhan. Kaushi Chauhan or Wasim Akram. Kaushi Chauhan or Wasim Akram. Or else Mamata. Mamata? Mamata?
The species that have same number of
Yes?
neutrons. Same number of neutrons.
The nuclei which have the same number of neutrons,
Neutrons and but different
but different atomic number. Same
Yes.
number of neutrons, but different atomic number and mass number. Different atomic number and mass number are known as isotones. So isotones have same number of neutrons. Where it is, which is correct in that?
Sir, option A.
Option A is correct, right? Option A is correct. Next, question number 21. In the reaction, this they have given. Deuterium and tritium they have given. Deuterium and tritium, helium and one neutron. If the binding energies of deuterium, tritium and helium are respectively A, B and C, then the energy released in this reaction is, please tell me, energy release. Energy release. Which option is correct? Energy release. Energy released. Huh?
Option B, C minus A minus B.
Yeah, this is. Why? Because for this it is A, for this is B, this is for C. C minus of A plus B. That is the energy. C minus A minus B. That is the answer. What is this? In any fission process, the ratio of mass of fusion product divided by mass of parent nucleus. Mass of fusion product divided by mass of parent nucleus is always less than 1.
Equal to 1.
Less than.
Less than 1.
Yeah, less than 1. Less than 1. Okay, na?
Yes, sir.
Right. Next question. What is the next question? See. What is the next question? Fission of nuclei is possible because the binding energy per nucleon in them is. Fission of nuclei is possible because the binding energy per nucleon in them is increases with mass number at high mass number, or decreases with mass number at high mass number, increases with mass number at low mass number, decreases with mass number at low mass number. Which option is correct?
Sir, option B.
Sir, option C.
Option
C.
Option C is correct. Further,
C.
option D is correct. Yeah, decreases with mass number at low mass number. Right. Next, 24th. The binding energy of deuteron is 2.2 million electron and that of helium is 28 million electron volt. For deuteron, that is 2.2 million electron. For deuteron, for hydrogen atom, what is the binding energy? 1.1 million electron volt. 1.1 million for hydrogen atom. For deuteron, that is 2.2 million electron volt. And for helium atom, that is 28.3. This is 28.3 or 4 million electron volt. Here they have given 28 million electron volt approximately. If two deuterons are fused to form the helium, then the energy released is. Already we did it, I think. What is the answer? 23.6
milli electron volt. Yes, sir.
million electrons. Yes. 23.6 million electrons. Next question is.
Sir,
Yes. Yes. Next question. In a
Sir.
radioactive, yes. Who is that?
sir,
Yes, Vai Kumari.
sir, in question 23, answer should be option B, I think. Please check.
Yeah, D is correct only, no? So 25, question number 25. In radioactive material, the activity at a time T is R1 and at a time T1 is R1, T2 at a later time T2 it is R2. If the decay constant of the material is lambda, then they're asking the question like this. In a radioactive material, the activity at a time T1 is R1 and at a later time T2 and at a later time T2 is R2. This is R2. If the decay constant of the material is lambda, then they have given the statement. Which one is correct? For first one, that is lambda. Next, lambda T2. Which option is correct? Yes. Which option is correct? You write here. R1 is equal to R naught
Option A.
T1 and R2 is equal to R naught into e to the power of minus lambda T2. Now do it R1 by R2 is equal to e to the power of minus lambda T1 plus lambda T2. Therefore, R1 is equal to R2 into e to the power of lambda, you take as common T2 minus T1. Is it correct or not? It is T2 minus T1. Lambda you take as common, that is T2 minus T1. If you take minus as common, T1 minus T2. So
Yes, sir. Option A.
R1 is equal to
Option A is correct.
minus UT of epsilon T1 minus T2. Which option is correct?
Sir, option A.
First option is correct. Right. Next question. See, this they ask one time. Now only we did this one, I think. Important question, 26. Two radioactive substances A and B have decay constants pi lambda and lambda respectively. At t equal to 0, they have the same number of nuclei. At t equal to 0, they have the same number of nuclei. The ratio of number of nuclei of A to that of S will be, just now we did it, that is. Just now we did it. Do it please. Which option is correct? Now only we did it. The same procedure you can do. Same procedure. This procedure we can
Which formula n is equals to n naught into e to the power minus lambda into t.
do it. Which answer you got?
Wait, sir.
I'll wait.
Sir, 1 by 2 lambda. Option D.
Question,
Option D. 1 by 2 lambda.
answer,
Yes, sir. 1 by 2 lambda.
1 by 2 lambda you got. Yeah, 1 by 2 lambda is correct one. 1 by 2 lambda is correct. 1 by 2 lambda is correct. How you get 1 by 2 lambda? Same, this one only can find. So that is, instead of R1 and R2, you write N1 by N2. So this one only you can write. N1 by N2, that is equal to e to the power of minus lambda into, what is T1? So what is T1 and what is T2? Oh, for that you can see, that is, what is that one? The ratio of one is 5 lambda and second one is the lambda, no? 5 lambda, lambda. That is minus minus a 5. That is, this is a 5, no? Yes, that is 5. 5 minus, I'll do, I think, where should I do? Why? Because eraser will work or not, but you can check it, please. Eraser will work, we'll check it. Clear all, huh? Eraser will work, huh? Yeah, eraser is, no, it's not working yet. With other pen it is working. Okay, I will write for this. With this I will write. What is that N1 by N2? N1 by N2 is equal to e to the power of minus 5 lambda plus lambda. Means
Minus 4 lambda T.
e power minus 5 lambda. So this they have given. But what you know, that is
Sir, minus
4.
Sir, e to the power minus 4 lambda.
Yeah. That is equal to e power minus 4 lambda into t. So N1 by N2 is equal to 1 by e power 4 lambda into t. But what is N1 by N2? That is equal to 1 by e whole square. Means 1 by e square. Means that 1 by e square is equal to N1 by N2 is equal to 1 by e square. That is equal to 1 by e to the power of 4 lambda into t. So you can equate those two. So 2 is equal to 4 lambda into t. T is equal to 1 by 2 lambda. That is the answer. This thing. Read out. Next 27. So I think now I'm going to stop this session. Why? Because at 11:30 you have math class. You have math class, and again I will take the class. In the afternoon also I will take the class. Please attend. We will finish all these questions. Okay. Right. Vinila, Meghana, Charmi.
Okay, sir. Sir,
Vinila, please call me after this class. Please call me.
Yes, sir.
Mai Kumari,
Yes, sir.
please you attend regular. Please you come afternoon session. We'll discuss all these questions. Okay?
Sir,
Yes, Pawan.
yes, sir. Sir, I have still dot in tomorrow's question, sir.
Which one?
Sir, thermodynamics 13.19 problem.
Okay, we will do in the evening session. Okay?
Okay, sir.
13.9, problem number 13.9.
Sir, 13.19.
Okay. We'll do. Okay?
Okay, sir.
Right.
Thank you, sir.
Thank you.
Bye, sir.